Hello students, welcome to Legacy IAS Academy. In today's video, we are going to discuss about Nobel Prize in Physics that has been awarded for the year 2023, especially when the scientists have worked in the area of the subatomic particles, and we'll try to understand that what is the science behind the subatomic particles and what is the contribution that has been made by the three scientists who were awarded Nobel Prize in this particular year. So first of all, to understand that which are the scientists that has been awarded the Nobel Prize. So first of all, we have Pierre Augustini. The second scientist is Ferenc Krauss, and third scientist is Anne Louis. So they have been awarded collectively for their work or the experimental methods that they have used to generate attosecond pulses of light. Now, attosecond pulses of light basically refers to a light which is having, basically we can say, a pulse duration of almost 10 to the power minus 18 seconds, and thus by generating the attosecond pulses of light, they were able to study the dynamics or the movement of electrons at the subatomic level in the area of matter sciences. So let us try to understand this in more detail, but before that, let us try to have a brief understanding about each of the scientists who were awarded Nobel Prize. So first of all, as you have discussed, it is Anne Louis. She was born in year 1958 in the Paris city of France, and she got her PhD in 1986 from the University Pierre and Marie Curie in Paris itself, and currently she is a professor at Lund University in the Sweden. Similarly, we talk about the second scientist who is, or physicist we can say, Pierre Augustini. He got his PhD in 1968 from the Aix-Marseille University in France, and currently he is serving as a professor in the Ohio State University situated in the Columbus region of the United States of America. Similarly, the last scientist, third, we have is Ferenc Krauss, who was born in 1962 in the Moor region of Hungary. He got his PhD in 1991 from Vienna University of Technology in Austria, and currently he is serving as a director at Max Planck Institute of Quantum Optics, Garching, and professor at Ludwig Maximilians Universität at München in Germany. Now let us try to understand that what is the context in which they have been awarded the Nobel Prize. So first of all, if we talk about the generation of the pulse of light, which is of 10 to the power minus 18 seconds, and it is believed by the scientific community that such generation of light will have huge potential applications in the field of diagnosing diseases and also developing electronic gadgets. If we talk about Anne Louis, Pierre Augustini, and Ferenc Krauss, they have been awarded for the experiment which have given humanity new tools for exploring the world of electrons inside atoms and molecules. Now, how they have made it possible, and why before there were certain limitations that we cannot see at the subatomic level, we cannot see that what is happening and how the electrons are moving. So we'll discuss in the later slides. But also they have demonstrated a way to create extremely short pulses of light that can be used to measure the rapid processes in which electrons move or change their state of energy. Now, to understand this, first we have to understand about the structure of an atom. And if you look at the structure of an atom, we can see at the center we have the nucleus. Nucleus is composed of protons and neutrons, and around this nucleus we can see there are electrons that keeps on rotating or moving at very high speed. Now the problem is that whatever methods we have to look at the structure of atom or look at the change in position of atom, till now we could only see how the atoms are moving within a molecule or matter. Now, how the electrons or how fast the electrons are moving, we do not have clear idea because they are moving at very fast speed. Until now, we did not have any kind of method by which we can capture the movement of the electrons. And in this regard, if we try to understand, if we try to have this understanding that this is suppose nucleus, and as you can see, electrons are continuously moving around the nucleus. But the problem, as we have discussed, is electrons are moving at such a high rate, such a fast rate, that it is impossible to observe them in the real time. And thus, the work of these three scientists in this regard has brought humanity closer to observing and studying the movement of electrons by producing pulses of light that last only attoseconds. Attosecond, as we have discussed, is 10 to the power minus 18 of a second, and for a long time, femtosecond photography was considered the maximum event. Now, what is femtosecond? Femtosecond refers to the 10 to the power minus 15th of a second. And thus the production of shorter pulses light at the attosecond level did not seem possible till now, and till the works of these three scientists have made it possible. And this is a very revolutionary kind of development that has happened in the field of physics, especially if you talk about at the subatomic level, or what you can say at the subatomic physics, and that is why they have been awarded the Nobel Prize. If we try to understand this in more simpler term, in more layman term, we can understand this something like this. For example, if you are taking picture from a normal camera having what you can say is very high shutter speed or very long duration shutter speed, and you try to take a picture of a moving train, the picture of moving train will look something like this. That means it will look very blurry. But on the other hand, if you are using the high speed shutter camera for taking the photograph of moving train, the picture of train will be more clear to you. The reason is behind very simple, because any moving particle, its accurate position, its real-time position can only be captured if the instrument you are using is able to what you can say open and close the shutter at very small and short duration of time. And this is something that has been made possible by producing attosecond pulses of light. One other example you can understand, that suppose you are taking a photograph of bullet that is piercing through the apple. Now obviously when you take a snapshot, what you will see? You will see that bullet has passed through the apple and apple has been destroyed into various fragments. But exactly the each millisecond by millisecond movement of the bullet cannot be captured by the normal camera. On the other hand, if you are using very high shutter speed camera, then as we can see from this lower diagram, we can capture the movement of bullets at a very shorter period of time, and we can have a clear snapshot of how the bullet has moved from point A to point B to point C before, after, and through the apple or any other particle. And thus attosecond science, if we try to understand this in more details, we can see that to observe any process, simply as you have discussed right now, the measurement must be made at the pace that is quicker than the rate of change or the rate of change of movement of the or the movement of the materials or electrons, whatever you're taking picture of, and that is how clear image of moving objects are generated. Now for observing the subatomic particles, light pulses are the only plausible solution, and thus the only plausible tool to capture the processes at the atomic level cannot be made indefinitely shorter. The reason behind this is very simple, because light consists of waves or vibrations in the electromagnetic field, and the shortest possible pulse would have to be at least one cycle in length, and this one cycle is nothing but the wavelength of the light. And thus for all sorts of light that is produced by the laser systems, the cycle used to take at least a few femtoseconds to complete. And thus if you are using light as a tool to capture the processes at atomic level, you cannot capture such processes, you cannot capture motion of electrons, because this motion is happening at more shorter duration at the attosecond level. And you have what kind of instrument? Femtosecond level instrument. And that is why till now it was impossible to detect the movement of the electrons in real time. Scientists were therefore unable to glimpse the motion of electrons with the existing technology. And thus with this revolutionary discovery of attosecond production of pulses, we obviously will see a huge implications in the field of physics, chemistry and biology as well. Now the question comes that how long did it take these scientists to develop this attosecond level of technology? So obviously the work has been going on for decades, and if you try to trace the journey of these three scientists especially, you can see it was in year 1987 when Anne Lhuillier discovered that if a laser light wave is basically passed through a noble gas. Noble gas, as you know, that is kind of inert gases such as helium, neon, krypton, xenon. So whenever a laser light is passed through the noble gases, it interacts with the atoms, and when it interacts with the atom, the electrons get excited because they are getting extra energy, and if they are getting extra energy, then they will emit also a pulse of light. And then she continued to work on this particular concept. Then further in year 2001, it was the Pierre Agostini who succeeded in producing and investigating a series of consecutive light pulses or flashes of light, in which each pulse lasted just 258 seconds. And at the same time, almost in the same years, the Ferenc Krauss was working with another type of experiment. He made it possible to basically isolate the single light that lasted only 650, attosecond. And thus, due to the combined effort of all these three scientists, these flashes of light have now made it possible to provide images of processes that is going on inside atoms, because they are also the light pulses that are having attosecond level duration. So the last and the most important question comes that what is the importance of this work for which they have been awarded Nobel Prize? So scientists all across the world, and especially also if you talk about the chair of Nobel Prize Committee, they have said that we have opened the door to the world of electrons by this revolutionary method of examining the electrons, and thus attosecond physics now will give us the opportunity to understand mechanisms that are governed by electrons. And thus, one possible application is in the field of healthcare, in the field of diagnostic and diseases, where we can study molecular level changes that is happening in the blood to identify unique diseases. Apart from that, the doctors in India, the scientists in India also have said that one other active area of research in the medical sciences can be use of this technology for finding therapies for the cancer care, because all the changes that are happening inside the body at molecular and submolecular level that can now be understood in much more better manner, in much more detailed and accurate manner by using the attosecond pulses of light. And other better understanding also of how the electrons move, how the electrons basically absorb energy, how electrons transmit energy can also help us in creating more efficient electronic gadgets, because most of electronic gadgets are also working on the principle of the movement of the electrons, atoms and all that. And thus what we can say finally, that attosecond science has a potential application in variety of area. Though this has been developed in the field of physics, it has applications not only in physics, but its application can actually encompass many areas such as medicine, many disciplines such as physics, chemistry and biology, and that is why this has been considered worthy of being awarded the Nobel Prize in this area. So I hope you understood about why and what is the field in which Nobel Prize in Physics has been awarded for the year 2023. That is all for this particular video. I hope you understood the concept behind this. If you like the video, please hit the like button, share it with fellow aspirants, as well as subscribe to our channel for more useful content. Thank you very much.